Next up, while we swap the computers out and reverse the polarity of the neutron flow, we have David Roure, Professor of E-Research and Director of the Interdisciplinary Oxford E-Research Centre, with a coordinating role, goodness me, this is a long title, coordinating role in digital humanities at Oxford. I don't know whether he's going to bring us down to earth or not, but he's given us the great title just before we go to our break of E-Research and the Demise of the Scholarly Article, also known as that thing that pays us and provides for our pensions. So without any further ado, as they power up the machine, brilliant, David Roure.
Thank you very much. Excellent. It's great to follow Chris. And in fact, Chris and I work in adjacent buildings in Oxford. Oxford Astrophysics is next to Oxford E-Research, but we only ever meet at events like this. And Chris just said to me, right, it's up to me to give all the answers now. So, let's have a go. So, as you can tell from the title, partly this talk will be about the demise of the article. I've become the end of the article guy for some reason. I'll explain why. But it's actually more balanced than that, because I'm also going to say later on, hang on, in some senses, things haven't changed much in 350 years. This was amazing, in 1665 and 1666. This was actually open science, right? Amazing. We're still talking about that today. More recent publication looks rather similar. So part of this story is it really still fit for purpose after all these years? And another part of the story is, hang on, it's worked for 350 years. There must be something right. Okay, so those are the two parts. Here's a big picture. Quite simplistic, turns out to be quite useful for discussion. So on the x-axis along the bottom there, I have the more people axis, right? Increasing numbers of people, citizens, scholars. On the y-axis, we have more computers, more processors, more cores, more storage, Moore's law, as our computer science colleagues would call it. And although I've put big data and big compute up on the left there, it's tempting to put big society here, but that might be confusing. So this is kind of big social over here. It's very interesting to look at this over time, and I'm going to focus in this talk on the top right, because that's where a lot of the attention is at the moment, but I'm not saying everything has to be top right. Air traffic control, I'm happy to have that down here. Don't necessarily want that done on Twitter just yet. Okay. So over the last 10 years or so, and it's great being at an event with sort of e-science in the title, because e-science is what we've been doing for 10 years, e-science or me-science or we-science. And really that sort of initiative, in the UK, a very coordinated initiative across multiple funding agencies, it led to a lot of investment sort of up around there somewhere. We call it e-infrastructure. Just over the last couple of years, there's been another big UK government investment in the high-performance computing area. So that's sort of taking us up there, and that's very important. That's the value proposition of the new computational capabilities. This is how we deal with big data. But the other thing that's been going on in perhaps a less coordinated way is this sort of the fact that everyone is now working digitally. We're sort of swimming in devices and in the digital world and using the web, and whatever discipline we're in a university, or whatever business we may be in, we're working increasingly online. And I actually saw separate communities emerging. You get the sort of e-science, e-research community having events. E-science was predicated on this notion of the data deluge. It wasn't called big data then, but 10 years ago it was the data deluge. Meanwhile, other communities are getting together because they're working digitally. You can do amazing things when you're working digitally. So I've been trying for this period of time to bring those two things together. That top right quadrant is really where the action is. Now, we can put different names in there. I'm just going to call it the fourth quadrant for this talk, although there's a small reason for that comes up later. But we could call it the future. We can call it all sorts of things. It's where the big society, the big networks come together with the big data and the big compute. So it's where new data is being generated. It's new forms of data. It's also where new forms of data are being analysed, as we've just seen in Chris's talk. Right? So this is a very interesting space, and it's certainly where my e-research centre in Oxford is working. We could have a debate later about where this arrow goes. Exactly as Chris said, in fact. Some people say, well, actually, we've got a long way to go towards the right still, because there's still a lot more people who are going to engage with the digital world. And others say, we're going to run out of people, and it's actually the vertical axis that's going to keep us going. And that's cool, yeah. That's quite a compelling argument for the longer term. It does seem that there will be more automation, more of those robots, as time goes on, and we have to think about that future. But we might be coming over to the right first. Therefore, when we go to university now, it isn't just the Large Hadron Collider and our physics colleagues building big experimental devices to generate lots of data who are working with big data. It's happening across every discipline. And this is reflected very much in recent well-documented changes in methodology. We call it data-intensive research, we call it data-centric research, we call it fourth paradigm research. Here are just a few of the sort of classic articles in this area. The first one was actually by Dykell, who was previously the chief exec of the BBSRC Research Council in this country. The title says it all. Here's the evidence, now what's the hypothesis? The complementary roles of inductive and hypothesis-driven science in the post-genomic era. The point being that instead of coming up with a hypothesis, doing an experiment, getting some data, which is perhaps a traditional approach, new results are being obtained by starting with the data and then coming up with a hypothesis. And this is really is generating new science that wouldn't have come about in any other way. Whether that replaces the old method is a bit controversial. Wired magazine said it does. The end of theory, the data deluge makes the scientific method obsolete. I don't necessarily agree with this, but we could discuss that. That sort of dominance of data and the notion of correlation over the notion of that sort of explanation and causation of data is coming through very much in parts of the big data movement at the moment, including this book from a colleague in Oxford Internet Institute, Victor Meyer-Schoenberger, which focuses on business data. And then Microsoft produced this book a few years ago now called The Fourth Paradigm, which is about the methodology of data-intensive research across many different areas. And it's quite interesting when they present that to a multidisciplinary audience, because some of our colleagues, especially in arts and humanities, and I work in digital humanities, do wonder about that enumeration. Why is that the fourth paradigm? We've always started with the data, so we just think that's the first paradigm. But anyway, that's why I call the fourth quadrant, because I think that's what's interesting about that space. And our funding agencies in the UK, at least, and I know we have a broader audience than that here, have really now invested in big data. So this is actually in our Research Council's UK slide showing the investments going on in the big data area currently. I won't go through all of this in detail, but you'll notice that it includes commercial as well as research data. I'm actually particularly engaged with this thing at the top here, the social media data, which is definitely in the intersection between business and academia, and is a really exciting new form of data, particularly for social science use. Not just because you can answer questions you used to, but in new ways, but you can actually answer entirely new research questions. And particularly, you can work real time, which isn't how it's always been done before. So these are the changes in methodology that we're seeing. A lot of activity today. What happens as we go forward? Well, this is a slide that I used 2 or 3 years ago now at a Dagstal seminar called Future of Research Communication, which led to something called the Force 11 Manifesto. Oh, yeah, it must have been 2011, which some of you will be aware of, which is about the future of research communication. And I put this up as a kind of science fiction slide, but really this is reality today. This is how we're doing research today. So, for example, I don't walk into the office, design an experiment, go into the lab, do it, write it up and publish it. I go into the office, I log on, and I find out how my experiments are getting on, because they've been running all the time autonomously overnight. Some of them take nanoseconds, some of them take months, but it's an ongoing process. These are information flows. It's a living system. And the same way that you log in, and we might get told about people who cited your papers or recommendations for the papers you should look at. Exactly the same technology telling me what new results have occurred overnight or elsewhere in the community, what I should be looking at. So it's really a degree of automation that's already in place. It's interesting that with these increasing numbers of objects, digital objects out there, the data, the software, we're getting better at actually getting the system to automatically do the curation on that. Not everything can be looked after by humans all the time. That's a fundamental scaling challenge in this. So we're seeing that sort of thing. We're seeing self-repair. We're seeing, I particularly work with scientific workflows. We're seeing workflows that used to work that have stopped working because they depend on the world staying the same, and the world doesn't stay the same. But actually, we can get better at getting them to fix themselves, which is interesting. And all of this means the systems are getting on and doing research by themselves. And that raises all sorts of questions as to who owns them and what happens when something goes wrong and who is responsible. And that's that automation axis on that first big picture. That's where we're going in the future. We have to deal with these scales of automation. The moral is, machines are users too, machines are readers too, machines are authors too. Right? We don't just think about people. In that fourth quadrant, we have to think about the machines. And then in one slide, this is the talk you just had from Chris, which was a splendid introduction. Zooniverse is a great example of the fourth quadrant in my picture, because it's where the people are coming together with the digital engagement and with the science. But it's very interesting to think about who's working for whom in that quadrant. So sometimes the humans are making use of the computers. Online communities are a really good example of that. Other times it's almost like the other way around. The computers are making use of the humans. The computers are getting humans to act as like human subroutines, to do things that computers aren't so good at yet. For example, classifying the galaxies. So is it the case that in Galaxy Zoo, somehow the humans are enslaved to the computer, like robots? Well, no, because of exactly what Chris said. On the one hand, humans are being used for this sort of data analysis task, but then there's the whole other piece with the discussion fora, the talk fora, the other tools that Chris showed, whereby new science is happening. So the citizens aren't just subroutines, they're actually becoming very specialist scientists in very particular areas. And new results are coming out as a result. So, really interesting example of the fourth quadrant. In general, in that area, I think we should look at the implications of that on our, and I'll use the phrase knowledge infrastructure in general. And by knowledge infrastructure, I mean publishing, I mean libraries, I mean our memory institutions, I mean websites, and just, everything that we're working with, social and technical. So this is socio-technical systems. Is really our knowledge infrastructure. And I think we have to think about that and where that's going, because we're all part of that infrastructure. So now a little story, which leads to the title of this talk. Some of you may have been at an event called Beyond the PDF, or an event called Beyond the PDF 2, which occurred in Amsterdam a few months ago. And I know there were people in the audience who were there. And so there was this accidental provocation that occurred. So when you registered for the event, you had a chance to give your vision for the future of publishing in so many 100 words, or maybe it was 100 words. And I did that like everyone did. And then one day I got an email saying, results of the jury, we have not accepted your vision. However, would you like to present a poster? And I thought, well, I didn't know there was going to be a jury, and present a poster beyond the PDF too? Really? It just didn't feel very beyond. But I do like posters as a means of interacting with people. And I had a separate challenge, which is that I was going to Amsterdam via Hong Kong and I didn't want to carry a poster. So I got out of this situation by asking a colleague in the Netherlands to print out on his home printer this poster, which is 6 pieces of A4. And what I did, as a sort of teasing thought experiment, was to write a paper in the year 2065. Since then, I've changed it to 2066, so I can make jokes about 2066 and all that, but that's another story. And it's... I did this so that I could write about the history of the paper, and one of those sheets, I think it's that one, basically says, describes the period in the history of the paper which coincided with the Beyond the PDF event, and it's called Period of Confusion. And it just gave me a chance to get back at the event. But the previous page here, just as part of my narrative being written very quickly to reduce this thing, I have a section that basically said, the demise of the paper around 2030 can be attributed to several factors and 8 things, right? And that's what got everyone's attention, and that's how I became the end of the article guy. Now, I hadn't thought very hard about those 8 things. I was just doing that to get to the next page. But they turned out to be quite interesting. So what I'm going to do now is just run through those quickly, and then I'm going to come back with the other thing, which is, but hang on, there must be something right about papers as well. So, yes. So it's no longer possible to include the evidence in the paper. I've referred to this as container failure. This actually, PDF exploded today when the scientists tried to paste in their Twitter fires. This provocation to me actually occurred at, again, an event some of you were at the RPA conference, whenever it was, on a panel. Richard Madeley was organising it. And we were talking about sort of encapsulating data with publications. And one idea is, well, you can put the data in the PDF. It's like, well, no, not if it's a Twitter fire hose. So that was the provocation there. So yeah, we're working with big data. You're not going to stick it in the publication, whatever form it may take. Related but different, the idea of being able to reconstruct science and reconstruct research. well, at one time it might be sufficient to have a paper to describe an experiment, so you can go and reconstruct it. But now there's a load more going in there in terms of the various artifacts, particularly digital artifacts. I'll come back to this website, My Experiment, later, which like Zooniverse may have the aesthetic of 2007, but we've been running for 6 years a website where scientists are exchanging scientific workflows. But they actually exchange bundles of stuff. It isn't just like a workflow here, which is a bit of process, a bit of code, if you like. It's all the other things. It's the results, it's the logs, it's the metadata, it's the paper. It's those bundles of things. And you need all this stuff now to do the reproduction. There's a subtle point here, which I don't want to dwell on, but happy to discuss later, because there's a very big movement at the moment about reproducibility and about sort of reproducible research, that phrase, those two words, particularly coming out of ClimateGate. And it is really important to be able to take some research and actually sort of replay that and see if you can get the same answers and so on, and you should have everything in place in order to do that. But that isn't reproducibility, as I was taught reproducibility when I was taught as a scientist 30 years ago, because actually reproducibility is when you take something and you independently get the same results. That's the really useful thing to happen. If you take everything exactly the same as someone else and get the same results, it's less interesting. That's a subtle point to worry about later. We write papers in quite a siloed way. We write them for a very well-defined readership. And the kind of research that's going on today, and this is the list of UK sort of grand challenges across the research councils, really is very interdisciplinary. The grand challenges are definitely interdisciplinary. It's hard for people to reuse the narratives that are being written for other parts of the community. So we need to make it easier to transfer research between different parts of the different communities and different parts of communities. So again, that isn't the traditional way papers worked. So there's a challenge coming from the cross-disciplinarity. This picture I'll come back to later, but this is my big data elephant in a big data center on the left, then a sense-making network on the right. And my argument is that machines are users too, as we said before, and there's the increasing computerization part, but what we really need is this thing on the right, which is people and machines working together in this sort of overall sense-making network. So I'm not just saying it's all automated and we've replaced humans, it's actually this combination. Something we just heard from Chris, and you're all very familiar with, is the notion of the number of people involved in various different ways in a piece of research lead to really what a Hollywood-style credits for authorship on a paper. And we're still being forced to have these arguments about how we fit everything into a list of co-authors, what the order should be, how the semantics of that ordering varies from community to community. But actually, digitally, it's not that hard to have a Hollywood-style cast list, give credit where credit's due, show the provenance of everything, account for all of this. So that seems to be another unnecessary constraint being imposed by our practices with paper. Zooniverse being a great example of cast of thousands. So here's my clay shirky picture, that's interesting. Do our existing mechanisms for quality control and peer review, for example, scale when we're working in an increasingly digital world with increasing numbers of digital publications occurring? So for example, if every institution is now becoming its own publisher, do our quality control scale to that? If we're publishing not just papers, but data and software and everything else, do they scale? And the reason I make this reference to Clay Shirky here is this notion of filter, then publish, or publish, then filter. So in some ways, what we do with publication at the moment is to we filter through peer review and then things get published. But perhaps what's going to happen instead is that there'll be a lot of publication and then the filtering has to occur so the good stuff rises to the top. But actually, that's already what's happening when you think about what's going on in publishing. So it's not so clear cut, but it is that. Where's the filtering occurring in this process? Number 7 of my 8, there are very standard ways of writing up things for particular communities and particular outlets, but actually we have to write reports for lots of other reasons as well. Compliance regulation is an example here. So really we have multiple forms of narrative around the same piece of research, and if you want to have impact, which is of course we're talking about a lot, if you want to influence policy, then you have other forms of narrative about the same piece of research. So there's the idea that you can have a bundle of stuff which represents a piece of research, but with multiple narratives. for multiple readerships associated with that is a more general purpose way of thinking of what a publication might look like in the future. And then finally, this is quite interesting. If our research communication system is somehow flawed or not or suboptimal and it could be improved in some ways, that means the investment that our research funders are making is actually not getting maximum return. So I work partly for the Economic and Social Research Council when we're looking at a project that's going to do some data collection. If that data will never be found by anyone, there was no point in doing that project. If that data could be found but couldn't be reused, there was no point in doing that project. If the data could be found, reused, and as people reuse it, they're adding value to it, you get extra return on investment. So really that test is very worthwhile. And if there are any constraints, this comes from another panel at the Beyond the PDF event, but if there are any constraints in that system, surely we should be looking at it. And the irony, of course, in all of this is that, scholarly communication is somehow broken. How are we fixing it? Well, we're holding conferences about it using scholarly communication. So maybe there's something flawed in there as well. So let's now just sort of pivot into the what's good about papers. So going back to this picture, the thing on the right is a kind of a social network, but it's a social network maybe of people and of computers, but they're exchanging stuff. The way social networks are built is that you have some kind of artifact, some social object, as it's called in the social science tradition, and in fact also in the Web 2 tradition. People come together around that, they discuss that. That's what forms links. You might discuss it in a room together, you might discuss it asynchronously, you may never meet, but that's what forms the networks. If you publish some data and someone else is then using that data, if you publish a paper, someone else cites that paper, this is building the networks. And there's a rich set of densely connected networks that we're producing all the time through publishing. And the more artifacts we create, the more different ways they are creating these things. So that network, we have to think about what the objects are in order to build that social network. And really, I think that's why papers have worked. Those knowledge exchange objects, which are papers, are the social objects in that network. They are the proxies for reputation. Citation is hugely important in this. And it's really teasing apart those things and asking what the new objects are. So it's not sufficient just to say, oh, everyone should publish data, because that isn't saying what are the objects, how they're exchanged, and how they're cited. And we're seeing those discussions occurring now around data, which is good. But what about around software? What around all the other kind of artifacts that we're using in digital research? So it's great that everyone's thinking about data. It sometimes feels like data's just been discovered, which is a bit odd, because we have been doing it for some time. But it's what you do with it that matters. Papers are about what you do with the data, so it's the methods. Exchanging methods is what builds capacity, it's what builds skills, it's what enables new science, it's what enables computers to help with the science, to help with the research. So really, we shouldn't just obsess with data. We have to think about what you do with it. It's not just big data, it's the methods as well. And I mentioned earlier our 2007 My Experiment website, been running for 6 years. This is quite interesting because we let researchers exchange these things called scientific workflows, which are a series of computational steps in doing sort of in silico research across many domains. Quite a lot of it is bioinformatics. But what we did was let people bundle stuff together in these things called packs, so you could associate with your workflow other stuff. We didn't dictate what it would be. And we let people do this, and then later on we came back and analysed 200 of these packs. Now these are interesting because this is letting people define what it is they actually want to share to do fourth paradigm research. Okay? Rather than forcing them to use papers, we say, okay, share anything you like. And now we can see what it is they're sharing. And it's very interesting. So that, first of all, there were the workflows being exchanged. Then we let these things called packs be exchanged where people could bundle in other stuff, typically Excel spreadsheets, PDFs, PowerPoints. We've now just finished a project, just last week in fact, called Workflow Forever, which actually came up with some standards for describing these bundles of things, which are available for anyone to use. This notion of exchanging research objects rather than papers. Papers could be part of them, multiple narratives could be part of them. These could be exchanged between multiple disciplines. They're boundary objects in some way. But actually, because they've got that executable part to them, it's taking us into an interesting space, and this is the future piece we saw in the science fiction slide earlier, where those things can be run by computer as well. And ultimately, this sort of goes back into a loop. So the latest thing there is not just bundling stuff together, which will get us a long way, I think, in the future of the papers, but it's also the computational side, the fact that computers are consuming, producing, doing science with these as well. So I want to sort of come to a close here. When we did the analysis of the packs, we did a little sort of word game on a blog, trying to come up with all the different ways of describing the behaviours that people wanted from these bundles. So reproducible was one of the words, but all these other things, they all tend to begin with R. We got up to about 14 words beginning with R at some point. This is just some of them. But this is quite an important exercise. By looking at what people were sharing, what are the characteristics, what are the behaviours, what is it we're trying to support in our scholarly ecosystem? And there's more information about those research objects and the standards available from the researchobject.org website. I want to leave you with another name for what goes on in the fourth quadrant, and it really plays very nicely with Chris's talk. It's this notion of a social machine. In 1999, Tim Berners-Lee, in the book Weaving the Web, defined a social machine as shown here. Computers can help if we use them to create abstract social machines on the web, processes in which the people do the creative work and the machine does the administration. It's very much what we've seen in everything that I've been talking about. And there are lots of social machines around. We're using them all the time. Here are a few. So Zooniverse is not just a social machine, it's a factory of social machines. We've seen 40 different social machines coming out of the Zooniverse social machine factory. Wikipedia, another great example. I mean, exactly what happens in a system like Wikipedia wasn't programmed in by developers on day one. It's emerged. The behavior of the system is socially constituted, the notion of editors and what they can do. Similarly, there are other citizen science projects here. There are citizen sensing projects, but also online communities. Ushahidi collecting data in the Kenya riots to share community intelligence. There are many, many examples. Some explicitly machines like we've got the Mechanical Turk on the left, where people are getting paid to do work. An interesting one, dual-purpose one, top left, is reCAPTCHA, which you all use when you're being tested to see if you're human or a machine, and you type in some words. You're actually helping transcribe some digitized text, right? So you're doing a bit of social computation there as well. And so we could talk about those, but what I want to do for this audience is just think for a minute. The evolution of research communication, of scholarly publishing, can be thought of, and the evolution of the ecosystem that we're all working in can be thought of as a set of social machines. Probably there are social machine designers in this room. There are definitely social machine users. Here's just a bunch of sort of logos stuck on a picture from beyond the PDF, but this is not comprehensive. There are so many other things you can put up there. Every time you create a website that's working with a community to provide some service that's some part of that scholarly publishing system, you're building social machines. So we can look at the whole thing from that perspective. And I hope that might be a useful suggestion to you, because we need to stop thinking about sort of, here are computers, and they've got users, but actually think of designing these socio-technical systems. That's what we're actually doing, a social machine. It's both of those things. And then when you release one of those into the wild, what you're doing is sort of trying to design the machine that's going to interact and evolve and give what you want when it's out there in the wild. It's a very different design process. It's not what we teach computer science students at all. Right? But that's actually what many people in this room are doing. You are social machine designers. So just sort of closing thoughts we could discuss later. I mentioned citation as being very important. So what are those objects? What are the social objects? And how does that sort of fit in with our scholarly ecosystem? I think that's a key discussion, it's a very practical way forward. Think about everything as an ecosystem of injecting social machines. I hope you find that's useful. And it's just, having now explained that everything is a social machine, that Zooniverse picture where you have the discussion for it is kind of the circuits in a social machine. Well, you can look at the whole of research. You can look at the whole of the process that you're part of as a big social machine. It's like all the scientists, all the researchers, all the citizens, and you together are a machine that's generating more science. So we're all cogs in those wheels. Thank you very much.